Welcome to section 8.4. We're dealing with multiplying and dividing rational expressions. Don't forget, a rational expression is a fraction as we go through. And the most important thing about section 8.4 is that we're going to factor. And we just spent the day before factoring different things. And so we'll work on a few factoring review questions before we start. But in this is about section, I want to start by using factoring skills to simplify. Again, we're not doing any solving, but to simplify our rational expressions. And they're expressions because there's no equal sign. It's just giving you the fractions and then asking you to simplify them down. So in order to do that, again, the most important thing is that we're going to have to factor. So I'm going to look at a couple of factoring things. In number 1, they ask you to factor x squared plus 5x minus 24. Well, we know it's a trinomial, so we look at the first term, which we can break apart as x times x, and we look at our constant term, the last term, and say, how do we get 24? Well, as I look at 24, I know that 8 times 3 is 24, and the reason I pick 8 and 3 is because 8 and 3 can somehow be manipulated to add to 5. Now, one of these has to be negative, though, to be a negative 24, and because I want a positive 5, I want the bigger number to be positive, so it's going to be a negative 3. So my two factors then are x plus 8, because it's a positive 8, and x minus 3, because it's a negative 3. Okay, and that's stuff that we worked on yesterday. For number 2, you'll notice we only have 2 terms, and when we only have 2 terms, we want to look for what's in common. And so what I'm going to do is, first of all, I see that they each have at least 3 x's, so I'm going to take out an x cubed. But the problem is they also are both even, so I know a number can come out of them. And I'm going to take a little time to kind of figure out what number. And to save us a little bit of time, I know that 36 is a number that goes into both. And if I pull a 36 out, 144 divided by 36 is 4. I had 5 x's, but I took 3 out, so I have an x squared left. And then I keep the minus. 324 divided by 36 is 9. And I had 3 x's, but I took all 3 out, so I can close my parentheses. Now, before I end this factoring question, I just want to say, can the parentheses, because it's still a squared term, can the parentheses still be factored more? And the answer is yes. To get 4x squared, we take 2x times 2x. To get a negative 9, we take 3 and negative 3. And this is a difference of squares. Okay, if we remember that from before. So I have that 36x cubed in front. And now I'm going to write my 2 factors for my difference of squares. 2x plus 3 and a 2x minus 3. Okay, and again, our goal is to completely factor so that we can simplify today. The last one we look at is 6x squared minus 17x plus 5. And you can do it a couple of ways. You can use the snip method, or you can just do a guess and check. I'm going to show the snip method a second. In the snip method, we make a table, and we say a times c in the first column. It has to add to b in the second column. Well, a times c is 30, and we want it to add to negative 17. So I start looking at ways to get 30, and I know that 15 and 2 can get me 30, but I need them to be negative, so they're both negative. And because negative 15 plus negative 2 is negative 17, I take each of these terms, negative 15 and negative 2, and I divide it by the value of a. And the value of a is 6. Once I divide it, I want to see if I can reduce. And I can divide the first one by 3. And if I do that, I get negative 5 over 2. I can divide the second one by 2, and I get negative 1 over 3. Because these are in reduced form, the bottom number becomes our x. So my first factor is 2x minus 5. 2x minus 5. My second factor, 3x minus 1. Okay, again, if you just guess and check, you would have found the same thing. Snip method ends up being slightly quicker. Okay, so we've covered factoring. Now I want to actually show you why the factoring is important. Take a look at number 4. What we want to do in order to simplify is we first want to factor, okay, and then the second thing we want to just cancel out like factors. And what I mean by like factors is they have to be the same factor in the numerator and in the denominator. So let's take a look at number 4. I can factor x squared, and I'm going to do that here, to x and x. I can factor 10 to 5 times 2, because 5 plus 2 gets me 7. So what I get on top then is x plus 5 and x plus 2. In my denominator, this is a difference of squares, so x squared is x and x. Negative 4 is 2 and negative 2. So I have an x plus 2 and I have an x minus 2. Now I'm going to switch my colors so we can kind of see how the canceling works. But as I look at this then, I notice there's an x plus 2 on the top and an x plus 2 on the bottom. Because there's one on top and bottom, I'm going to cancel out those like factors. So what's left in the numerator is an x plus 5. What's left in my denominator is an x minus 2, and I am done. You cannot cancel x's from top and bottom because there's a plus or a minus there. That's why we say we can only cancel out our factors. Okay? So let me go back to that other color again. Let's try the second one. I can factor x squared as x and x. I can factor negative 15 as 5 and 3, and the 5 has to be negative because I want it to add to a negative 2. So in my numerator, I get a factor of x minus 5 and a factor of x plus 3. And I'm going to do the same thing in my denominator. X squared is an x and an x. The only way to get 3 is 1 times 3, and 1 times plus 3 adds to 4. So I have an x plus 1 and an x plus 3. Okay, again, I'm going to change my colors because I see I have a plus 3 and a plus 3 on top and a bottom, so I cancel. I'm left with x minus 5 in my numerator and x plus 1 in my denominator. Okay, so what are we doing all of this lesson? Factoring, 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 and more factoring. Okay, let me go back. Let's do the last one on this page. Now this one's a little harder because we're starting with an x cubed. So I'm going to look at pulling something out first. If I look at my numerator, I can pull out an x, and I'm left with x squared minus 9. I'm going to deal with that in a second. I'm going to look at my denominator. They all have an x in common, so I'm going to pull out my x, and I'm left with x squared minus 4x plus 3. Now, I hope you can kind of see something up front, so let me change color again. If you notice, they both have an x in the numerator and a single x in the denominator, and we're going to cancel out those factors that we pulled out. So I'm going to take those out. Now I'm going to keep going back and forth, so 2 colors for you guys might be good too. As I look at this, now I'm going to factor what's left. X squared minus 9 is the same thing, and we've done this a couple times, so x plus 3 and an x minus 3. In my denominator, x squared is x and x. How do you get 3, 1, and 3? But they're adding to a negative 4, so they both have to be negative. So I have an x minus 1 and an x minus 3. So what do? Taking my red, because my red says cancel out, right? I have an x minus 3 in the numerator and x minus 3 in the denominator, so those cancel. What am I left with? X plus 3 in the numerator over x minus 1 in the denominator. Okay, now if you pull an x out of it, you can again cancel that up front first and then do the work. Or you could have just left this x in front right here and then just cancel them out at the end. It's kind of up to you. I just like to get rid of whatever I can first. So that's the first idea when you start to just simplify. Okay, we're going to flip to the back side where we're going to do the multiplication and the division. Okay, I apologize for that delay. Trying to get it to switch pages didn't want to work, but let's take a look. I'm going to, again, switch colors. Let me go back to the blue, and I'm going to continue to use red as what we do to cancel out. When you multiply, we know that when we multiply fractions, we multiply the numerator times numerator and denominator times denominator. And so I'm still going to do the same thing. I am going to, again, factor. So I'm going to first factor, and then secondly, I'm still going to, again, cancel out my factors. This really is exactly the same thing as we did on the front side, only I'm just going to have more factors on top and more factors on bottom. So let's start with this first one. They only have two terms, so I look at what's in common. They both have a 2x, so I'm going to pull the 2x out in front. If I take 2x out of here, the first term, I have an x left. Plus, if I take 4 divided by 2, I just get a 2, and I've already taken the x. Okay, I go to my denominator. X squared is x and x. How do you get 12? In order to get 12, I'm going to use 6 and 2, but one of these has to be negative, and it's going to be the 6 in order to add to a negative 4. So x minus 6 and an x plus 2. Now, you can do some canceling already if you want. I find it's easier just to factor everything and then cancel at the end. Now, this denominator of 2x doesn't have anything else, so we're just going to leave a 2x in the denominator. But in my numerator, I'm going to try and get 18. 18 is 6 times 3. If I need to get a negative 9, they both have to be negative. So I have factors of x minus 6 and an x minus 3. Okay, so let me change color a second. Now that I've factored everything, we want to change our color and we want to cancel out our factors. Well, if you notice, there's a 2x and a 2x. Those cancel. I have an x plus 2 and an x plus 2. Those cancel. I have an x minus 6 and an x minus 6. Those cancel. So we look at what's left. The only thing that's left is an x minus 3. Because it's on top, I can just say x minus 3 is my answer. If it were in the denominator, I'd have to say 1 over the factor of x minus 3. But in this case, again, it's on top, so x minus 3 is our answer. Let's take a look at the second one. Now, I'm going to put this second fraction over 1, so that at least I have a numerator and a denominator in both fractions. So I work on the first one. I'm going to leave this negative 2x squared. There's no plus or minus, so I don't have to do anything with it. My x squared minus 9 is a difference of squares, so I have an x plus 3 and an x minus 3. Times, I still have this over 1. In order to get 9, it's 3 and 3. So I have an x plus 3 and an x plus 3. Normally we write that as x plus 3 squared, but in this case I'm leaving them as separate factors so that we can kind of see. Now I realized I didn't go back to my blue, so we'll just cancel in blue this time. You'll notice I have an x plus 3 in the numerator and x plus 3 in the denominator. So those cancel. Now I look at, okay, nothing else can cancel, so I look at what's left. Well, I have a negative 2x squared and an x plus 3 in my numerator, and I have an x minus 3 in my denominator. Now, your book would like you to distribute this back out so that it's one single fraction again. So as I look at this, let's simplify. 2x squared times x is negative 2x cubed. Negative 2x squared times 3 is negative 6x squared, all divided by an x minus 3. And so leave your answer here. There are going to be times when I can say just leave it in factored form. As of right now, let's practice getting it back out there since nothing else can cancel. Okay? Last example of multiplication. We again factor the numerator. So there are only two terms, so what do they have in common? Well, they have a 6 that you can take out of both, and an x. So if I take a 6x out of the first one, you're left with x. 6x out of the second one, you're left with 3. Okay, denominator, in order to get 6, it's 3 times 2. but one of them has to be negative. So if I look at this, I know I have a 3 and a 2. Which one's going to be negative? Well, I want a positive 1. So the bigger number is going to be positive. The 3 is going to be positive. The 2 is going to be negative. All right, let's go to the next one. Negative 2 is negative 2 times 1 because that adds to a negative 1. So x minus 2 and x plus 1. My denominator to get a negative 8 is 8 and 1, but the 8 has to be negative to be a negative 7. So x minus 8, x plus 1. Okay, so we factor everything out. Now let's get on the right path again. Let's start canceling. I can do an x minus 2 on top and an x minus 2 on bottom. Those are gone. I can do an x plus 3 on top and an x plus 3 on bottom. Those are gone. I can do an x plus 1 on top and an x plus 1 on bottom. Those are gone. So now when I go to write my answer, let's look at what's on top. As I go across, the only thing on top is the 6x. As I look at my denominator, the only thing that's left is the x minus 8. So here is my simplified rational expression. Okay? Multiplication is just like the simplification we did on the front half. The division is where it gets a little bit more difficult. So let me go back, get my colors right. I'm going to go back and I'm going to give you a 3-step process. The first thing we're going to do is we're going to flip the back fraction. Okay, the second fraction maybe is the better word, but as we look at this, division is the same thing as multiplying by a reciprocal. And because of that fact, we're always going to take this second fraction and flip it. Okay? Once we flip it, we're going to factor like we did before. And then it's back to multiplication, so we're going to cancel out factors. Okay? Because once you're here, basically you're already working on the multiplication again, so you just go back to what we did on this left side. So let's start. As I look at this, my first fraction always stays the same. So 3 divided by x plus 7. Instead of division, I'm multiplying by its reciprocal. So I flip the numerator and the denominator. So my new numerator is x squared plus 6x minus 7. My denominator is 8x squared minus 8x. Okay, once I'm here, I'm going to start looking at factors. All right, so my first fraction, I'm just going to put my x plus 7 in parentheses. When I look at negative 7, to get 7 is 7 and 1, but the 1 has to be the negative in order to end with a positive 6. So an x plus a 7 and an x minus a 1. My denominator, there's only 2 terms, so we look at what's in common. They both share an 8x. So if I take an 8x out, I'm left with an x minus 1. So, what do? Now that we're in factored form, let's cancel out our factors. There's an x plus 7 on top and bottom, you cancel that. There's an x minus 1 in the numerator and the denominator, you cancel that. So when we go to write our final answer, we start with our numerator. What's still in our numerator is a 3. What's still in our denominator is an 8x. Now, if 3 and 8 could be reduced, you should reduce those numbers. But because 3 and 8 can't be reduced, you leave it as 3 divided by 8x. All right, let's do number 5. Same thing. I'm going to write this over 1 because I'm going to flip my fraction. We leave my first fraction as x squared. Let me change my color again while I'm thinking of it. We leave our first fraction as x squared minus 1 over x minus 4. We flip my second fraction, 1 over x squared minus 2x plus 1. Okay, let's set this equal. Factor the first one. This is a difference of squares. X squared minus 1 is x minus 1 and an x plus 1. My denominator is still an x minus 4. I'm just going to stick it in parentheses. Times, I still have this 1 on top. To factor 1, it's 1 and 1, but they both are negative to add to a negative 2. So x minus 1 and another x minus 1. And again, normally we say squared. Don't in this case because we want to cancel factors. All right, let me go back. Here we go. In my numerator, I have an x minus 1. In my denominator, I have an x minus 1. So we cancel them. As I look at this, it doesn't look like there's anything else to cancel. So I write my answer. In my numerator, it's an x plus a 1. My denominator, I have an x minus 4 and an x minus 1. Now, over on this side, you see we simplified some of this out. I don't want you to simplify a denominator. So don't FOIL a denominator. Okay, because the denominator, like we talked about in the graphing, will help us find specific things about graphs. And so I want to leave it in this form. Numerator doesn't tell us as much, denominator is important. Okay. Number 6 is one of the harder ones because I start adding numbers in front of the x squared. So last one. I start by, again, rewriting the first one. And I flip the second one. So 2x squared minus 5x plus 2 is on top now. And 2x squared minus 11x plus 5 is now on the bottom. All right, here we go. Let's factor. My first fraction, I have an x minus 5 in the numerator. There's only 2 terms, so what do they have in common? Well, a 9 and an x. What am I left with if I pull that out? X minus 2. Okay. And then this is where it starts getting a little bit more difficult because you got to start looking at these combinations. Now, in order to get 2x squared, I know I have to have a 2x and a single x. Same thing on the bottom. So I'm just going to write this up front because I know when I factor a 2x squared, one has to start with a 2x, one has to start with an x. Now on the front we use snip method, and you can do that, it just will take you extra space down here at the bottom, which is fine. I'm going to look at this a little bit different, and I'm going to start at the bottom here. How do you get 2? The only way to get 2 is 1 and 2. But if you wanted to add to a negative, both negative 1 and negative 2 have to be the negative. So the question is, what combination works to get negative 5? Well, 2 times negative 2 would be negative 4, and another negative 1x would be negative 5. And this is kind of a play around with it, or show your snip method underneath. Same thing for 5. In order to get 5, it's 1 and 5, and they both have to be negative. And I need to add to a negative 11. So 2 times negative 5 gets me negative 10. And then another negative x gets me negative 11. And I kind of know this going through just because I'm kind of looking at this and I've done factoring. But again, if you need snip method, please go ahead and do that. Now I'm going to switch these a second. And I'm going to start looking at what things cancel. Well, it only looks like the 2x minus 1 canceled. So as I look at this, I'm kind of going through, okay, what do I have on top? Well, I have an x minus 5 and another x minus 5. And in the denominator, I have a 9x and an x minus 2 and an x minus 2. Now, we said don't FOIL out the denominator, so I'm going to start with the denominator. As I look at this, the 9x stays in front, but I have 2 of the same factors, so I'm going to say x minus 2 with a quantity squared. Because I want my denominator to look good without actually having to do any work to FOIL it out. My numerator, I'm going to have to FOIL. So x times the x is x squared. Negative 5x and a negative 5x is negative 10x. And then negative 5 times negative 5 is a positive 25. And so as we look at that, that's going to be our final answer. Okay? Again, biggest thing, don't FOIL a denominator, but you definitely want to FOIL a numerator. So I wanted you to get the idea at least. With factoring, it's going to get more difficult when we put a number in front of x squared. But otherwise, if you understand factoring, this ends up being a really nice section. So that's it for section 8.4. Please start the homework if you can. It is a worksheet, but we want to get you going ahead of time so we can help you with your factoring.